Hi all, welcome to new class. Today's class is about the time response of a system. So, the time response of a system is the output of the closed loop system as a function of time, and it is denoted by C of t. And the time response can be obtained by solving the differential equations governing the system. Then this is a closed loop system. So this is the input and this is the output. So the output in S domain C of S is given by the product of the transfer function and the input. So here the closed loop transfer function is given by C of S divided by R of S, and that is equal to G of S divided by 1 plus G of S H of S. So the response in S domain. So response in S domain is C of S, and that is equal to R of S into G of S divided by 1 plus G of S H of S. So the time domain response C of t. So we have to find the time domain response C of t, and that is obtained by taking the inverse Laplace transform of this product. That is the product of the transfer function and the input gives the output in S domain, and on taking inverse Laplace transform of this product we get the time domain response C of t. That is response in time domain C of t is equal to L inverse, that is Laplace inverse of C of S, and that is equal to L inverse of R of S into G of S divided by 1 plus G of S H of S. And the time domain, that is the time response of a control system, consists of two parts. One is the transient part and the second one is transient response. Transient response and steady state response. Steady state response. The transient response shows the response of the system when the input changes from one state to another. One state to another. And the steady state response shows the response as time t approaches infinity. So, the time response of a control system consists of two parts, the transient response and steady state response. Next is test signals. The knowledge of input signal is required to predict the response of a system. So, we have to find the input signal, and in most of the systems the input signals are not known ahead of time, and also it is difficult to express the input signals mathematically by simple equations. Hence test signals which resembles the characteristics of input signals are used to predict the performance of the system, and the commonly used test signals are impulse, then step signal, ramp signal, parabolic signal, sinusoidal signal. So these are the standard test signals: step signal and also unit step signal, ramp signal, unit ramp signal, parabolic signal, unit parabolic signal, then impulse signal and sinusoidal signals are the test signals. Let us study the test signals in detail. First one is step signal. The step signal is a signal whose value changes from 0 to A at t equal to 0 and remains constant at A for t greater than 0. And the step signal resembles an actual steady signal. So, at t equal to 0, its value is A and remains constant at A for t greater than 0. And unit step signal, and also its value is given by r of t is equal to a into u of t. So a into u of t is the step signal and u of t is the unit step signal, and its value is u of t is equal to 1 for t greater than or equal to 0 and u of t equal to 0 for t less than 0. So u of t is the unit step signal, and here if the magnitude of A equal to 1, it is called unit step signal. So if A equal to 1, then it is called unit step signal. So its plot resembles a steady input. Next is ramp signal. The ramp signal is a signal whose value increases linearly with time from an initial value of 0 at t equal to 0. So this is the graph of a ramp signal, and it resembles a constant velocity input to the system, and its value is given by r of t is equal to a into t for t greater than 0 and equal to 0, greater than or equal to 0, and equal to 0 for t less than 0. And here also if a equal to 1, then it is called unit ramp signal. Unit ramp signal. Next is parabolic signal. In parabolic signal, the instantaneous value varies a square of time from an initial value of 0 at t equal to 0. And this is the parabolic signal graph. So it resembles parabola, and the parabolic signal resembles a constant acceleration input. Constant acceleration input to the system, and its value is given by r of t is equal to a into t square divided by 2 for t greater than or equal to 0 and equal to 0 for t less than 0. Here also when a equal to 1, it is called unit parabolic signal. Unit parabolic signal. Next is impulse signal. A signal which is available for a very short duration is called impulse signal, and it is denoted by delta of t. And ideal impulse signal is a unit impulse signal which is defined as a signal having 0 values at all times except at t equal to 0. And its plot is like this, that is, this is r of t and this is time t. So for a short interval of time, the signal is available 0, 1 by a. So delta of t is equal to 0 for t not equal to 0 and limit t1 equal to t1 tends to 0 integral minus t1 to t1 delta of t dt equal to 1. Since a perfect impulse cannot be achieved in practice, it is usually approximated by a pulse of small width but a unit area. So, the area of impulse signal is equal to 1. And the response of the system with input impulse signal is called weighting function or impulse response of the system and is denoted by C of t. So C of t is the inverse Laplace transform of the system transfer function. That is C of t is equal to L inverse of R of s G of s divided by 1 plus G of s H of s, but this is impulse signal, so R of s is equal to 1 for impulse signal. So we get to the Laplace transform, inverse Laplace transform of the transfer function as the impulse response. So impulse response is the inverse Laplace transform of the transfer function of the system. So the standard test signals are step signal, the time domain equation of the signal is A, then the Laplace transform of the equation is A by S. For unit step signal it is 1, here 1 by S. Then for ramp signal, time domain equation is A into T, its Laplace transform is A by S square, and for unit ramp T, then 1 by S square. For parabolic signal, time domain equation is A t square by 2, Laplace transform is A by S cube. For unit parabolic signal it is t square by 2 and 1 by S cube here. For impulse signal, time domain equation is delta of t and Laplace transform is 1. Also note that the integral of step signal is ramp signal, and integral of ramp signal is parabolic signal. And also the derivative of, that is d by dt of step signal, derivative of step signal is impulse signal. So this is about the basics of time response and test signals. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.